Hi guys, now let's solve question 11 from the final of April 2012. This question pertains to the main broad category of reactions, and we'll look at substitution and elimination at the same time. I really like this question because it's a little tricky, but it allows you to comprehensively analyze all the possibilities pertaining to SN and E reactions, so substitution and eliminations. The question is, which of the following product is least likely to form the from the reaction below? So we've given this reaction, and I've actually gone and actually labeled the hydrogen, so each carbon should have 4 bonds, and I saw that this carbon has only one metal. Second bond was with the benzene group, and the third one was with the carbon, and the fourth one, the hydrogen, is always there. And what they're asking is really least likely to happen. You see that the first thing I noticed was that the solvent, the reagent over here is CH3OH. And what I'm trying to say is, over here, this is a very poor nucleophile. This is a weak nucleophile. So straight away, I know that if it's a weak nucleophile, the nucleophile isn't really, determining the rate of the reaction. And we know that when the rate of the reaction is not dependent upon the nucleophile or the base, then it's a weak, then it's a E1 or SN1. Either it could be unimolecular substitution or unimolecular elimination, and only the substrate basic is what really matters. So if it's E1 SN1, then the mechanism is already there. Now I have to see what are the products being formed. If you see A and you see product D, they're actually the same. In product A, the two metal groups are actually pointing the same side. In product D, they're actually pointing the opposite side. So it's basically cis versus trans, or E versus Z. E is the opposite side, so that would be E alkene, and this would be Z alkene, and similarly this would be cis alkene, this would be trans alkene. There's different ways of signifying or indicating the alkene which is in question. But you also notice that other products which are, for example, this product has the methoxy group over here instead of fluorine, so you know that substitution is going on. And you notice that there's methoxy group but it is attached to a different different spot, different carbon. So if you notice that, now you could go ahead, but what is really interesting about this answer choice C is that not only you do have a methoxy group, but you also have a double bond. So you're not only having E1, but you're also having SN1, which is really not possible. SN1, either you could go by SN1, either you could just substitute, or either you could just eliminate. So because there are both things happening at the same time, this is the least likely to take place. So how did I how do you get choice E? I wrote down a small diagram of the rearrangement taking place. So whether it is SN1 or E1 for choice E, I'm saying, so this is the diagram for choice E. Whether it's SN1, E1, doesn't matter. The first step is the carbocation rearrangement or carbocation formation. That happens when the bond between the carbon and the halogen, which is in this case is chlorine, breaks. Once this bond breaks, the carbon has a positive charge, and then you have a hydride shift. This hydrogen, actually the hydrogen that I labeled here, was actually goes there, and when it goes there, the positive charge comes on this carbon, which means now the methoxy group can actually, so this our alcohol, methanol, will actually attack on this position, and that's why you have this methoxy and methyl group at the same position. So that's choice E. That's pretty much possible because you're forming a carbocation rearrangement. Choice A and D are very much possible because how would elimination take place? The first step is, again, because it's E1, you get rid of the carbon-chlorine bond. Once you get rid of that, there's a carbocation, and then the methanol can come in and take away this hydrogen, and this bond will go over there, forming a double bond. And if it comes from the back side, then you will form a trans alkene, and if you come from the front side, it will be cis alkene. So it's elimination, quite straightforward elimination. Choice B is the most straightforward substitution. SN1, again, you have to get rid of the carbon-chlorine bond again, and then the positive charge, and then the methoxy group directly attaches right here for to form this bond. So methoxy is directed in. But choice C, again, is not only forming elimination, but is also attaching a methoxy group. So it's also substituting as well as eliminating, which is least likely to take place. So answer choice C is our correct answer.